This is Rob Vaughn with Red Castle Resources, a contractor at the U.S. Forest Service Remote Sensing Application Center. Today I'll be talking about the TEUI Geospatial Toolkit 5.2. The title of my talk is the new TEUI Geospatial Toolkit, How Consistent is Your Mapping? Before I get going, I'd like to thank many folks who make the toolkit possible. The IRDB, the Forest Service, for funding us. Larry Ling, the National Soils Program Manager, for support. Kevin McGowan, the RMIM Program Leader at RSAC, who oversees the development of the toolkit, as well as many others at RSAC. I'd also like to thank our NCSS partners, Dave Hoover and Tom DeVello, who provided very valuable feedback and support over the years and ideas that have really improved the toolkit overall. As well as many others out there who I've talked to over the years who provided feedback and guidance and support. So today I'm going to be talking about the TEUI toolkit and its history, and also I'll be talking about the toolkit software itself and how you might be able to use it and some of its functions, as well as give a brief example using soil survey in Kootenai, the Kootenai National Forest in Montana. So for those not familiar with TEUI, TEUI stands for the Terrestrial Ecological Unit Inventory, and the purpose of TEUI is to classify ecosystem types with similar capabilities and potentials for management. And this is a system that was developed in the U.S. Forest Service. It borrows a lot of principles and mechanical workflows from soil survey, but the product has more of an integrated ecological, geological, and soils integrated map unit. More information than, say, a traditional soil survey map unit. The toolkit itself is an ArcGIS add-in and is designed to facilitate and streamline the landscape mapping process. The tool is designed to be a part of the mapping process, not to be an end-all tool, but simply to be a part of it. So what does the toolkit do? In its most basic form, the toolkit itself just runs zonal statistics, and we display the results of those zonal statistics from polygons and underlying rasters as graphs and as tables. So users can visualize the information that's under each polygon in graphical form, or look at it in a spreadsheet form or a tabular form, or export it for use in other programs. I think most important with any tool is to talk about what it doesn't do. And so the tool itself, the toolkit itself, is not a predictive soil mapping tool. It does not provide predictions of soil classes or soil properties like clay percentage or organic matter, nor does it provide estimates of uncertainty. Now the toolkit can be used during the development of those products, but it itself will not produce these things. I would certainly point people towards more accepted tools within NRCS, such as RSAC, the Soil Inference Engine, or other predictive tools such as random forest, support vector machines, other machine learning tools out there that are available in platforms such as R or Python that have had success in the digital soil mapping community. The toolkit itself is just one tool among many, and I've said that before here and I'll say it again, is that I don't think that you can create a full soil survey, a published product, or a TEUI using just one tool. Many folks out there realize that there's several tools along the way that they need. It just depends on what stage you're at and what you're actually trying to accomplish. I think the toolkit serves a purpose at some points during that process, but it's not going to be the one-stop shop or the end-all tool. So a little bit about toolkit history. The toolkit's been around for a while. 2001, when it was first developed as a set of ERDAS Imagine models. Now ERDAS Imagine is a more commonly used remote sensing software, and so many folks in the community did not use ERDAS, nor didn't have a license for it. Most folks were using ArcGIS, and so the tool itself was migrated to ArcGIS platform, and that was performed by iCube, the company out of Fort Collins. They had done the original programming for us. And we had some issues with the tool. overall, some error messages and things like that. And so we decided in 2008 to bring the programming in-house, the development of the tool itself, and that gave us a lot more freedom to fix errors and to respond to user feedback and add features and things like that. So that was really wonderful. But there was also a lot of limitations with the tool in terms of how it was developed using Esri ArcGIS functions. And so there were some limitations in there where we realized that the tool had kind of hit a wall, and so we decided in 2013 to reprogram the tool from scratch using our own custom programming, which was great. We were able to speed the tool up dramatically. It was more robust. It was more streamlined. And we thought it would be a product that would be more receptive to more users. So a little bit about the Toolkit program or TEUI program at RSAC. Obviously, we support software development and maintenance. Just the overall development of the tool. If there's issues, there's bugs, we can fix them in-house. We can do all of that there. If you're working on Forest Service lands, we provide, people get in touch with us and we provide any geospatial products that we can. Things like digital elevation models and derivatives of those, imagery, things like that. So if you're working on Forest Service lands and you're interested in gaining some of those products, please feel free to contact me at any time. Obviously, help desk, tech support, project support. If you run into any issues with the tool, maybe you have an idea, something you'd like to see, some kind of new function developed for the tool, please get in touch with me. We also provide project support around the country to various mapping projects, whether it just be doing simple things like providing imagery or actually getting more involved in terms of modeling and other things and other ways we can support the projects. And obviously outreach, getting out to conferences, getting the word out, training, on-site training, online training, things like that. We provide all of those resources to users. So our long-term vision for the toolkit really centers around this toolkit engine in the middle. And what that is just this zonal statistics generator. We take those zonal statistics and you can leverage them in many different ways. Obviously, we have the TEUI toolbar as it stands now, but we see it as more of a modular tool where different resource communities and users can develop modules that interpret those zonal statistics and leverage them in ways that they are looking for in their projects. So whether it be soil survey or TEUI, they're very similar. They're probably going to look at the zonal statistics or calculate various derivatives of them in certain ways, whether for quality control or insurance. Sometimes the nomenclature is just slightly different. Soil survey might use slightly different terms than TEUI. They're really the same thing, but users often get tripped up on those simple nomenclature issues. So if we can provide some consistency within the resource, I think most users will be more happy with that. Obviously, if you have ideas, please get in touch with us. We're more than happy to talk with you and hear what you're thinking. So toolkit functions were developed to be as simple and straightforward and streamlined as possible. A lot of issues with the previous versions. There's a lot of convoluted processes in there. So with this one, it's just creating a simple project folder. Now the project folder basically is a store for the zonal statistics that you're generating. It also stores the links to all your data on your computer. And so it's a container, and that's it. The data management interface is really where the user starts interacting with the tool. We have the analysis features or zones, and those can be polygons, lines, points, or rasters, thematic rasters. Users can also designate a map unit column, and now it doesn't have to be a traditional soil survey map unit or any kind of symbol name. It's just simply an attribute column that is a common identifier. And the zonal statistics for each polygon under that identifier will be aggregated up into a new value that users can utilize. Tool obviously accepts raster data. It can be continuous data. It can be thematic data. It can be integer data, floating point data with decimal places, things like that. As long as ArcGIS accepts the data, we should be able to handle it. The new software has these great flexible graphs and interfaces that folks can interact with. Users create the graphs themselves by selecting, the polygons that you're using and map units or features, the raster sources, things like that. We can also handle radial data, things like aspect, so users can visualize that easily, graphs. Some of the tools that we have in the toolkit recently, we've added a sample design tool called the Condition Latin Hypercube Sampling Tool. This is a stratified random sampling approach without replacement. I'm sure folks in NRCS and or in the digital soil mapping community are very familiar with this tool. You'll see some resources down below where you can learn more about the tool and exactly how it works. Now our tool was based on some of the work from the package that's available in R. Essentially users identify the raster data that they're interested in, and the tool will, along with the number of points you're interested in, you can add in things like cost layers, so how much effort it takes to get to a certain spot, exclusion masks, things like water, basically no-go areas, places you cannot go, and you select an output location. And what the tool does is try to, in multi-dimensional space, obviously with the restrictions you've imposed, select a number of sites that are representative on the ground to try to best recreate the original histograms. And what really this tool is doing is constraining the analysis or the random points, if you will, to real places on the ground. And it's very helpful, especially with digital soil mapping, to ensure that your sample sites essentially cover the range of variability across your site. So it's a very useful sample design tool. Some of the products, essentially you get a shapefile back of the points, the number of points you selected. In this case, I believe it's 15. And you also get appended to that the latitude, the longitude, and the individual raster values under each one of the points. So you can see the aspect, slope, and DEM. And we've also added in the histogram, the original data histogram that you could select with the points that were selected overlaid on top of the histogram. So you can see how the individual sample points are distributed across the range of data that you put into the tool, which is very helpful to ensure that you're adequately covering that range of variability. We also have you're able to plot the objective function versus the iteration. So if you're not liking the results from the tool, you can look at that graph and maybe select more iterations to run the tool. So it's kind of more of a quality control aspect. We also have the Connotative Legend tool. So for those unfamiliar with the Connotative Legend, essentially a Connotative Legend is each letter in the legend symbol, a letter or number, represents a range and characteristics of some underlying data property, whether it be slope, aspect, elevation, whatever have you. And so this tool is really neat because it'll help you evaluate existing map units to ensure that they, whether they're phased out for some range of slope or other property that you have a raster for, it'll allow you to do that. Essentially, to use the tool, users select input raster data. It can be either discrete or continuous. You essentially go through a standard kind of classification process, if you will, of classifying your data and assigning for each class either a letter or a number. You can also save this classification. You can import the classification, which is nice for, you can use the same classification over and over again for multiple projects. Or if you want to do this in an iterative process, you don't have to keep typing in the classification schemes. Essentially, the tool goes in and looks at under each zone or under every polygon the majority value and assigns the polygon the letter or the number that you selected for that class, and then concatenates them all together into a single symbol at the end. So again, it's a great tool for areas maybe where you're just doing initial mapping, you're just getting started. You want to start stratifying your landscape a little bit, understanding maybe there's two polygons next to each other you've identified in your pre-map that really have the same geospatial qualities overall, and you want to merge them. This tool will help you do that. And it's also good for evaluating existing mapping conditions where you kind of maybe know what the classification scheme should be and you just want to validate what's been done in the past. We have the ability to export the statistics, which is really nice. So if you are more of an Excel whiz and you want to work the data up in that world, that's great. You can export the data. If you want to bring it into R or do anything else with it, this is the way to do it. We can export either the data by individual polygons or by map units or both. We can also export the original histogram. Now, when we run zonal statistics, we capture the entire histogram under every polygon for every data layer or raster layer that you put in. ArcGIS just calculates the value, and so there's not much you can do with that, but we capture that whole histogram. So you can export that histogram to be used in other programs, if you will. Maybe you want to start looking at different percentiles of values in that histogram, something like that. You could do that as well. You can export selected raster layers or bands. The toolkit handles multi-band rasters, so you can export just individual bands if you'd like, and also the type of statistic. If you're just looking for, say, the median or the mean, and you don't want all the other statistics, you don't have to export those. We have another tool that we developed for some folks working down in the Southwest. They were working on some initial mapping and wanted a tool that would quickly help them validate the map unit assigned at the plot level to the map unit assigned at the polygon level over their project area. So we have a quick little tool that looks at the map unit symbol for the polygon, checks it against the point or plot data, and flags those where there's a disagreement. And if you right-click on the individual point, you can right-click and say zoom, and it will take you right to that area and let you, the scientist and the expert, decide which one is right and which one's wrong. Maybe it's just a simple mislabel. We also have a standalone version of the toolkit, the TEUI.commandline.exe. So you can run the tool in its basic form, that statistics generator, if you will, in a command line. This is really nice because you can integrate it with other scripting languages, things like Python or C++. So you kind of get that zonal statistics nugget, and then you're able to do with the products what you want to do. It's up to you, but it's a nice little tool to be able to put into your scripts. We use it at RSAC for our existing vegetation mapping work. It's sped that up quite considerably, just trying to generate the zonal statistics because the toolkit is so powerful. And then that gets brought over to R and Random Forest and other programs. One thing we're trying to do is adapt to the future. We want to integrate some machine learning and data clustering tools out there to really push the toolkit towards more of a quantitative analysis tool on the mapping. So right now we are currently working on developing a version of Random Forest within the toolkit that would rely on the Random Forest package that's available in R. But this would be a GUI interface of that tool. So folks that maybe don't have any experience in programming in R, but maybe want to try this to classify a map or do other things like that, or maybe make a digital soil map, they'd be able to use our tool to do that in a nice, simple, and easy way. So some of the applications of the toolkit, obviously TEUI and soil survey are the two main applications of the toolkit, and that's what I've been discussing today. Things like initial mapping, updates, but also doing the quality assurance, quality control for map units, for individual delineations, providing documentation, whether it be tabular or graphical, for each map unit. Maybe you want to put that documentation in a binder, maybe you want to submit it with something. You can do that, obviously with the toolkit. You can print out any of the graphs and tables and things like that. There's plenty more applications out there, one being the ecological site descriptions. This is becoming more and more on people's radars these days. The toolkit is already mentioned as a useful tool within the Interagency Ecological Site Handbook for Rangelands. And so I think it's a good tool to help describe the range and properties and things like that that you're seeing within your ecological sites when you're documenting them. It's just, again, it's not the end-all tool. It's not going to create a whole ESD for you. That's still up to you, the scientist and the expert. But again, it's just one more tool in that process. We do provide free self-paced online training that's available through our website. You'll see the link below. If you just go to the website or you Google TEUI Toolkit, our website will come up, and you can go ahead and take that training at any time that you'd like. We do also provide on-site training too for various user communities. So if you are interested, please get in touch with me anytime. This is our website where you can download the tool. You can download the GUI version, the ArcGIS add-in. You can also download the command line tool as well as the user guide. There's some detailed instructions on how to download it. There's also resources on there for examples how people have used the toolkit in their daily workflows, and some links to the training, frequently asked questions, and also my contact information. If you have any questions, issues, or concerns, feel free to get in touch with me there. So I'm going to move on now, talking from the tool, and show a simple soil survey example. This is intended to be just a very high-level, basic example of the tool. I'm sure folks will see this and see many other ways that they think the tool could be used, and that's wonderful. But again, this example is just meant to be a very high-level, basic use of that tool. So today I'm going to focus on the Kootenai National Forest, which is the Survey Survey Area MT634. And all the data that I'm going to be showing today and using is available from the NRCS Soil Data Mart and the Geospatial Data Gateway. It was just simply downloaded from those websites. So if you wanted to look at that yourself, everything's right there for you. Again, Montana 634, it's about 2.8 million acres. There's only 5,200 polygons, so it's not a very intense map. So this analysis is kind of broad in that sense too. It's also 91 map units across that whole survey area. And I'm going to work through this example just in a basic project form, how you might actually interact with the tool and conduct a similar analysis, so you'll be able to see kind of the workflow here. So obviously you just select a project presentation, you make a folder, and say this is my project folder, and you're good to go. In this case, we've moved on to the data manager, the next button over. We've said we're going to use our map unit polygons. We've identified the column and the map unit symbol as the column to aggregate our statistics on. And then we'll add in our raster data sets, aspect, curvature, DEM, slope percentage. Very basic data sets. I'm not going to use them all today, but just wanted to show you an example of doing or performing an analysis. Toolkit starts off processing. In this case, it's about 1.4 million cells per second. Depends on your computer and other things on how fast it goes. Here, 2.8 million acres for all those different data sets took only about 7 minutes on my computer. So it doesn't take very long. Here's the graphical interface, if you will. On the left, you'll see the graph series. This is where you select the individual features, the type of graph you want to see, the rasters, whether you want to view some of the statistics on the graph kind of as a set line, so you kind of get your bearings on the histogram and understand that. Up top, you can select to normalize the graph. Obviously, if you're looking at a frequency of cell counts and the values, there's a lot more raster cells under an entire map unit than there is under just one polygon. And so if those counts are extraordinarily different, you'll need to normalize them, or you may not see the histograms for an individual polygon when you compare it to a map unit. You can also select the chart type, aerial, line, point, or radial for aspect data. Down below is the chart window. That's where the magic happens. The graph will appear. You can also have various axes. And then to the right is just the legend. This is where the individual data series and things like that you've selected will appear. So today I'm going to kind of cherry pick, if you will, map unit symbol 102. This is just the second one in the line. I picked it. The one thing to keep in mind here, these are lacustrine terraces. They're family level, so they're kind of high. It's a con association, so relatively pure. It's only got 10% of minor map unit components. And it only comprises about 62,000 acres in this survey area, so out of 2.1 million acres. It's not very much. Anyway, the values to consider in this analysis that I'm looking at came directly from the published Surgo data set in terms of the representative values for slope and elevation. So if we're looking at the low value for slope is 0%, the representative value is 8%, and the high value is 15%. And of course, next door you'll see the elevation low is 610 feet, 869 feet, and 1128. So map unit 102 we're looking at here is a graph of percent slope. This is just a simple area graph of the whole map unit. So this is taking all the raster cells under all the polygons that have a map unit symbol 102. And on the graph you'll notice that there's 3 lines, standard deviation, average, and then a lower standard deviation as well. I'll kind of zoom in a little bit so you can see those better. And you'll see the actual value. So that's the average for the map unit. And that's not what's published in the Surgo data. You'll see that down below. And those are not always mean values, the representative values. So in this case, it's a little high, but that's just what it is, that they don't always have to match. It's not what we're always expecting. Now we'll do the same thing and look at elevation. You'll notice as we zoom in here, the average elevation is 968 feet, almost 969 feet there. And the representative value for this map unit is 869 feet. So the average is a little higher than what the representative value is, but it is still less than the high value. So it should be okay. We'll just continue on our way in running this analysis here. One thing you can do if you're interested, in this case it doesn't really provide much extra benefit, but just for your knowledge, you can add multiple axes to your graph if you'd like with different data types. They don't always have to be the same. So you want to think about the normalization and other things like that as you go ahead and create those. But just one more thing you can do with the tool. So map unit 102, kind of zoom in again here. We'll see our values, the same ones we just saw before with an average of 14.52. This is a map unit percent slope by feature graph. And so what we're seeing is all of the features within map unit 102, they're lined up from left to right based on ascending order of average or mean slope value within the polygon. So you'll see down in the x-axis, those are the feature IDs within the map unit. And this is a great graph to look at in map unit overall to see where you might have some outliers. And so in this case, if we look at it, as we zoom in, this graph here, we'll notice that there's a maximum, a minimum for each feature. There's a mean, and you also have a moving standard deviation around each of those. And one thing to notice here is that 36% of the map unit polygons have a mean slope that's greater than 15%, which is the high representative value for this map unit. So for the rest of this example, I'm just going to pick two. I'm going to pick 2 polygons, and this particular one is the worst one. It has an average slope within the polygon of 54%. Just want to remind you that the representative value for percent slope within this map unit was only 8%, so there seems to be something off there. The second one I'm going to pick is right on the nose, right at just about 8% slope at the average there. That should be our kind of central concept for this map unit, and one that we'll use to compare that first polygon to. So let's take a quick look. This is a percent slope overlaid on top of a hillshade with a little bit of transparency. It gets a little texture. Map unit 102, the feature 3335 on the left. This is the feature that had a map unit average of 8%. This is probably what we're looking for in terms of like a modal concept, if you will, for that map unit. On the right, you'll see map unit 102, feature 2573. This is our worst case scenario, where you'll see that the map unit has very high slopes within it. So keep moving on. Feature 3335, this is our representative value, kind of looks like a lacustrine terrace again. That's kind of what the concept of this map unit is. I've also added on the tabular data for this particular polygon, so you can look at tabular data for a whole map unit, or you can look at it for just an individual polygon. And then obviously you'll see the polygon highlighted there over the digital imagery. You'll notice that it's kind of out in the open. It's not near any major rivers or anything else like that. So feature 2573 had the average slope of 54%, really high. You'll notice that it's also in a kind of a riverine valley environment, kind of a sidewall there. Probably not a lacustrine terrace. So right off the bat, we can just visualize that and say this is probably not right. My guess is it was just simple mislabel, something simple like that. That would have been caught, you know, if you use the toolkit just to investigate all those polygons within a map unit, it would have been quickly realized that this one was not correct. So map unit 102, feature 2573, versus the entire map unit. So now we're looking at a graph of percent slope for the entire map unit and comparing feature 2573, which again is the one with the higher slope values in it, using an area graph. And so really quickly just visualizing that, we can see that the distributions of slope values under the individual polygon and the whole map unit, they don't align. We would expect those to be a little bit closer shape in terms of their distribution, and they're not, so we probably have an issue. One thing we can also do is quickly look at the map unit 102 overall. Now we have feature 2573, which is in the green, which is, again, does not share a similar distribution to the overall map unit. And then we have feature 3335, which is right at 8%, right at kind of that modal concept, the representative value. The shape is more similar in terms of its distribution to the overall map unit than it is not like it. And so here we can probably conclude that this particular map unit polygon was just simply mislabeled and should be investigated a little bit further with respect just to slope. Now that doesn't take into consideration all the other factors that go into making a map unit and why they're there. But when we just look at the slope values, something is probably not right. You also notice that the background for the map unit graphs here are white. Just up in the upper right-hand corner, you'll see you can turn on the white background if you want to print them or you just want to visualize things with a white background, you can do that. The print button is also right next to it, so you can export these into a JPEG or a PDF, things like that. Looking at elevation, again, you'll notice that the elevation here, there's a few polygons that are higher, but 52% of the polygons in this case are greater than the representative value for elevation, but there's only 3% of them. So there's just 2 or 3 polygons that are a little bit off in terms of elevation. Again, not a big deal, and still up to the expert soil scientist in the area doing the work to make that determination whether it was a good or a bad call. The toolkit's not going to tell you that. You still have to do that work yourself, and really the judgment lies with you, the soil scientist. So rather than continue down the same path we just did with slope, you'll notice that you could do that for elevation, but we'll pass on that today and just use the slope as an example. So take-home messages today. Toolkit is still a very useful tool for TEUI, soil survey, any kind of landscape mapping. It doesn't matter what you are. If you want to run zonal statistics using features or zones, and you have underlying raster data and you want to get some statistics from there, and you can use the toolkit. It does not have to be for TEUI, soil survey, whatever have you. It's great for working with initial or existing mapping. Really, it's about consistency. The idea, concept behind the tool is just one that is helping you to become a more consistent mapper as you work through an entire quad or a forest or a whole survey area. It's going to allow you to check and see how consistent you are and make sure that your delineations are within the range of characteristics that you're expecting. We're not going to tell you where things are inconsistent just yet. We're not going to flag things for you and say, hey, you need to go do this or change things. That's really up to you, the expert. We're hoping to get to a more quantitative way of doing that in the future, We'll see where that goes, but really, again, it's still up to you, the expert, the soil scientist, the TEUI scientist, to make the judgment call with your data in your project area. We're always open to new ideas and things on how the toolkit can improve, so please get in touch with me. My information's on the TEUI website. If you have any ideas, you have any issues, anything with the tool, I'm more than happy to talk with you and to work with you in that process. So I just want to thank you for taking the time to listen to this webinar today. And again, feel free to get in touch with me at any time should you have any questions about the tool or run into any issues. Be happy to work with you. Thank you.